Hello everyone and welcome to a new tutorial. It has been a while. I haven't been posting or preparing tutorials for my YouTube channel, but I'm back. So I have very interesting and exciting news. In the following months, I will be preparing and uploading new content on simulation, particularly urban climate for urban climatology research and analysis, not only for researchers, but also for practitioners and for anyone in local governments who want to use these tools to analyze the different environmental and climatological aspects of the urban environment. So I will be preparing a series of different tutorials on how to do simulations. First on thermal comfort, simulations using LiDAR, which means light detection and ranging, simulations on grasshopper using Ladybug, and also I will be creating a series of research methods tutorials on how to perform or conduct different meteorological and environmental monitoring using a variety of remote sensing and monitoring devices. So I will be producing a lot of new content and material for my YouTube channel, and I hope you find it very useful and enjoyable. Today, I will introduce one of the tools that I found that is really, really useful, very easy to use. For everyone. Well, the name of the tool is the UMEP. The UMEP, it's the Urban Multi-Scale Environmental Predictor, which is a climate service tool. It's not only designed for researchers, okay, but it's also for different type of practitioners like architects, climatologists, people in urban planners, urban designers. It's very suitable for students studying any type of, for example, sort of majors like geography, planning, design, in the built environment for researchers. So this is a plugin that has been developed by a group of researchers, top leading researchers in their field. You can find here the key names, basically Freddie Klimberg, Ting Zun, and Sue Grimon, Jihao Tang, and Niels Wallenberg, but mostly Limberg and Grimon who have been here behind this specific tool. There are renowned researchers in the field, so you know that you feel pretty confident on using these simulation tools. Now, UMEP combines the 1D and 2D models, mostly from remote sensing sources and basically raster and shed files to conduct different type of scale independent urban climate estimations. This is the website. If you just if you just search in Google UMAP manual, and you put the urban multi-scale environmental predictor, you will find a lot of information. I'm not going through this manual itself because it has plenty of information about the different tools. It has an introduction, very clear information how to cite it if you're going to use it. Obviously, it's very important this because there is a lot of work from the researchers. We have to acknowledge their work when we're using their tool. The manual can be cited in this particular way, and then the tool, or when you refer to the tool, this is the other um, way to reference it in your citation. So please don't forget to cite the software when you're using it. There is a community, there is a mailing list, there is a repository, etc. There you have a lot of support if you need it. Um, Here they have a YouTube channel. They have some introductory videos. If you want to have a look at them, please go and check. They are very interesting, very well done, very well produced videos. I particularly will focus on how to use specific tools from UMEP, and I will give you a lot of the hits and tips on how to use it, tricks to overcome some of the sort of problems that you will find when you are using the tools, and also tricks on how to speed up your process. So um, I've done some research and I couldn't find for so many of these tools particular videos, so I have to learn by myself or following the tutorials. They have a website here of tutorials, number 13. You can follow the step-by-step. I will use some of the information here for you to show you how to do the things, but also I'm creating my own set of tutorials with my own data sets, basically because here the data is already provided for you. But the question is, what happens if I don't want to use the data for this particular location, in, for example, Gothenburg in Sweden or London in UK, and you want to do your own analysis in your specific place or location of your interest, of you are doing a research in another part of the world. I will, in my video tutorials in future, I will show you how to use first the data they have, and how second, how to produce your own data sets. And once you master the way to produce data sets from LiDAR, from GIS information, from OpenStreetMap, then you will be able to identify any sort of location and do analysis in that particular location. Okay, the plugin has uh, preprocessors, processors, and post-processor tools, and we'll go through these in different video tutorials. It's not good time to overwhelm you about each and every tool that is there. They're very there is a very long list. Could be exhausting if we're going through them, but I particularly want to introduce the tool, how to install it, how to run it, and do a very basic activity in this first tutorial. So you can go to the website of the video tutorials. We can use these particular data sets they have. Why? Because it is easy. Then in the following videos, I will show you how to produce, how to obtain and create your own data sets. Okay, the data sets for the Gothenburg are here. You just click there and then you get the zip file. They have also a repository. If you want to go to the repository in GitHub, there is also a repository of work. Well, anyway, you have here the zip file. What I did is that I went here to the data sets. I extract all the content, and then this is what you get. And obviously they are, let me delete this. This is not part of it. This is what you get, a different type of information, and I will show you that information in QGIS. So the second thing you have to do is just go to the QGIS project. We can save it, save us, and then we're gonna create a project. The name will be UMEP, or let's put intro to UMEP. Okay, and we save in our data sets or video tutorial here, UMEP save. Okay, so we save the project. Don't worry right now about the particular project coordinate reference systems. Why? I will show you why you have to worry later. But the first thing, we're gonna install the plugin, the UMEP plugin. So you go to plugins here in the menu tab, manage plugins, and then it will open here. They install, you put all plugins. This is the list of all the available plugins so far. And then we just put here UMEP. So there are two set of plugins here. I will recommend you to install both. One, it is the tool itself that will be installed in your menu. But the other one is for processing. And this is very useful for running other tools that will be available in your processing toolbox. Okay, so let's install first the normal UMEP for your menu tab. And when that is done, then we can proceed with the processing for the toolbox. So this done, now let's install the second one, and I will show you the differences between both. And then we just close. Okay, so the first one, it's in the tab, as you can see, is installed here. You have the preprocessors like methodological data, spatial data sets. There are other tools here for urban heat island and urban morphology analysis. I will prepare different type of tutorials in future to show you how to use these tools. Then you have the processors, the auto-thermal comfort particular Solveig. So my next video tutorial will be on how to estimate auto-thermal comfort using mean radiant temperature model Solveig. You have energy analysis of urban energy balance analysis, solar radiation analysis. We're going to use this today just as an introductory example, an urban heat island generator, okay? And post-processors, which are basically for visualization and for analysis. We're gonna use one of these. Okay, so the first thing we have to do is in your browser of QGIS, identify where is your folder with the datasets from Göteborg. Okay, so here it's really useful. They put the projection system, which is the SWEREF 99 1200. So the first thing we do is we add the DSM, which stands for Digital Surface Model. Then we will add the DEM, which stands for Digital Elevation Model, and then the Canopy DSM. So before proceeding with this, I want to briefly explain what it means, each of them, if you are not, let's say, familiar with the terms. So the digital surface model, let's create a hypothetical section of the urban environment. So here you have the ground, right? Then you have some trees. Let's put a couple, and then you have buildings, correct? So once we have done this, so what is typically the DSM, or how is DSM calculated for UMEP? So for UMEP, the DSM, it stands for Digital Surface Model. So it includes ground, flats, buildings. Okay. So basically, it's a raster. It's a raster image. Okay, it could be in TIFF format, it could be in ASCII or .asc, it could be in XYZ, etc. But mostly it's TIFF. It could be also it's the most common is the Esri grid, etc. So what we got here, it's an image with pixel, which each pixel it contains the height or the altitude of, or the elevation. In fact, is the correct term is elevation of that particular point. So if your grid is 1 meter resolution, is that 1 meter is the average of the elevation for that 1 meter by 1 meter grid. If it is 0.5 meters, is much thin or finer, sorry. And if you have 5 meter by 5 meters, that it's coarser. Okay, the higher the resolution, the more precise your model, your digital model of elevation model, but the more time consuming it will be, the more computing time for the any calculation you want to do. Okay, so once have said that, so the digital surface model in this case includes the ground pixels plus the building. Okay, this is for UMEP. There are other digital surface models for other applications that includes also vegetation. But here UMEP makes a distinguished digital surface model from Canopy digital surface model, which is basically ground plus vegetation. So let's change the color of this to make it easier to understand. So this is basically the Canopy digital surface model. And finally, we have the DEM, which is only the ground, which only represents ground points or ground surfaces. Okay, so we have these three key basic digital models or raster models. Then also there is one called trunk. Let me change again the color so it's easier. We'll call the trunk digital surface model, which is ground and the trunk up to the height of the trunk of the vegetation. And it is used, if you have that information, is useful, but it is optional in most of the tools. Okay, with that information, now we can proceed and you will understand better what we are visualizing here. So the digital surface model, as you can see here, buildings and ground. Then we add the digital elevation model. In fact, the digital elevation model should be at the bottom. So as you can see the difference. Now, if we double click and we go to source, we notice here that it's already a coordinate system, a reference system has been assigned by default because these were already projected in that coordinate system, which is that correct. And if you can click here, you can see where it is, that coordinate system. Now, when we add the canopy DSM, you will notice that the question mark appears here because the layer has no coordinate reference systems, and it can cause a problem when you are running the tool in future. So what you have to do is just double click there and choose the SW EREF 99. So it matches and you put OK and the problem will be solved. As you can see here, the canopy overlaps properly, but it can cause problems in future. Or you can double click on the layer and then choose here the coordinate systems or find the appropriate coordinate systems from the list. As you can see, we can represent this also changing the symbology to pseudo color and use green, perhaps here, greens, and then represent the zero as no as transparent value. So as you can see here, the trees appearing with the height, sorry, on top of the buildings and the ground. So once we have done that, you have added the basic information. We have also buildings, which are the building footprints as shapefiles. If you open the attribute table, you will get a lot of attributes here. No, we're not going to use it today, but this is basically just to introduce the initial, let's say, tool of UMEP, and you feel comfortable understanding the basic concepts about canopy, digital surface model, and DEMs. We have also land covers, with it's basically the different type of ground surfaces and surfaces in general of the area. We can add it, but as you can see here, it's very difficult to distinguish because the values have been assigned from 1 to 7. So to visualize this properly, you have to click on the layer and go to style, load a style, and then in the data set, there is already a style provided for you. I recommend you to keep it because you will use it in future all the time you want to use this for visualization purposes. As you can see, the value 1 represents paved areas, the number 2 buildings, number 3 evergreen trees, number 4 deciduous trees, and so on. 5 grass, 6 bare soil, 7 water. We put OK. We can use this at the bottom. And then you can see the trees overlaying the areas. Now you can use the DSMs to color the area or shade the area, which you can change in the symbology. You can go to here the blending method and put overlay. So you will see different representations, but etc. That's not the critical complicated part. The visualization is very simple. Okay, when we have done this, we're going to run one of the basic tools of UMEP so you understand how this kind of works. We are not using any preprocessor. We're going to do this for in the next video tutorials in the following weeks. Processors, we're going to go to solar radiation daily shadow pattern. This is very useful for architects and urban planners and designers who want to understand the sun patterns. Okay, so we need here the building and ground digital surface model. Now I want to show you the difference between the UMEP app plugin from the tab, from the menu, compared to the processing tool. So if you go here to the same solar radiation, this is how it presents the graphic user interface. But if you go here to processing tools and you scroll down to UMEP and you go to processor and you search for solar shadow generator and you click, it's a slightly different representation so of the user interface. So you can compare here both. So in this one, you will get basically everything in a much, let's say, nicer way. It's much easier to choose the dates and the data, but here you will find, let's say, the Python in the processing toolbox style, but you will have a lot of information, extra information here, which is really useful. For example, they provide this metadata for you to understand what it is the solar radiation or shadow generator and how it works, what type of data you use, and then also how this is the method of calculation. So here you have the papers to cite the proper tool. And then you have a log, which is very useful when you run Python. You have parameters that you are going to input here. So you have a little bit more control of the parameters here, and you can run as a batch process as well. So let's keep it the simple one, but that's the main key difference. Some other tools are here are extra, like for example, the autothermal comfort tree planter that you don't find here in autothermal comfort, as you can see. And here in the processor, there is another one called Extreme Finder that you cannot find in this one. So that are the key differences. So now we already have opened this shadow pattern or shadow generator tool. We choose the DSM as a first one. We don't run for now the vegetation. I want to just estimate the shadows generated by the buildings on the ground. And later we will add the canopy, the vegetation canopy. So once having done this, you can also include facade shadows, but for that you need to have the wall height and the wall aspect, and they can be also calculated using the preprocessor. Where it is urban geometry, wall height and aspect. We will do this in a future video, so you can test it later. Just the DSM. Now we don't cast shadow at a particular time. I want to cast a shadow for a whole day. Let's choose a day in summer, which is in the northern hemisphere will be July. In the southern hemisphere will be June. So July will be, yeah, July, in the southern hemisphere, sorry, it will be January. Okay, so July is a good day, 21st of July. Then we can put daylight saving time or not, and then we put the UTC 1 because that it corresponds to Gothenburg. Now, another thing, it's very important if this is the Earth, and we have here Greenwich meridian. If you are towards the west of the meridian, you add, so it's a positive UTC. And if you are to the east, you have a negative UTC. So for example, New York is -5 UTC and Sydney is +11 UTC. Okay, so that's very important. Gothenburg is +1. So now we want to calculate the time interval for the casting shadows every 30 minutes. We go and choose our folder. So what you could do is in the tools in outputs, you can create a folder called daily shadows, and then we are going to create a new folder on 31st July and only buildings. Okay, and we select that folder. 21st July, only buildings, whole day, and then we can add the result to the project and we run. Oh, sorry, this is not an option now because we don't have the wall height and aspect. Okay, we run that. Oh, there is an error here. Let me see what is the problem. Okay, let's run it again. Hopefully we do the things properly. Solar radiation. Okay, so we choose our DSM. We choose the date, July. Let's choose a previous date. Maybe that's the problem. July 2020, 21st of July, every 30 minutes, date live saving, UTCI +1, and we select the folder. And we add the results and then we run it. So now it's running. obviously because we were casting something future, it didn't happen. So the shadow grids has been generated. As you can see, the shadow grid is there. I will turn off all the other layers so you can understand them. Here is the shadow. As you can see, there is no shadow casted from the vegetation. We just double click on that and we can change the opacity or transparency to 100% so we can understand better. You can change also the colors, obviously, but the color gray is much easier for visualization. Okay. So now, once we have done this, now we can run again the processor, solar radiation, and now use the DSM and also use vegetation DEMs. We choose the canopy DSM. Um, we have to select here the transmissivity of light through vegetation and the percentage of canopy height. If you don't have the trunk, you need this information. If you have the trunk, the percent of canopy height will be grayed out. Why? Because when you have the trunk, vegetation trunks on DSM, as I explained you before, it already knows what it is the distance between the ground and the top of the canopy for the estimation. But if you don't have that information, you assume that by estimating the average height from observation. So you need to go to the area, check what is the height of the tree. So some trees have the canopy mostly within the 25%, 25% of the total height of the tree. That means this is 75%, so three quarters and 1/4 of the height. But for some other species, this may be different, will be 10% or 5%, or for other, let's say, species like, let's say, the eucalyptus, you will have a completely different story in which it represents 50%. So you need to have a look at that. And also, if you want to calculate a specific transmissivity of light through the leaves, you may need to do it either by measuring directly or indirectly by observation or using a paper or a document that tells you what it is, or by default you can use the 3%. This is the most general rule. You can use it as a default. Okay, and then we do it every 30 minutes. We select the folder, and now we choose a new folder called 21st July Vegetation and Buildings. We choose that one, select folder, we add the result, and then we run again the tool. Oh, my mistake, I run it in the wrong day. So we have to choose July 2020, 21st, and then I will run it again. Okay, so let's discard. You will notice here the differences between February. Obviously, February you have a much low altitude of the sun because it's winter, and then you can notice the difference, the considerable difference. Okay, so let's turn off this. Let's turn on this. Let's change the symbology, transparency, maximum. Okay, but you can notice now the difference compared to the pure building estimations, and you understand here a completely different sort of estimations considering the shade from the vegetation. This is a very good, very simple analysis. Now, what you could do is visualize an animation. What you get if you go here to the outputs. So you will get a series of raster TIFFs from 4 a.m. up to 8:30 p.m. and then the average, or the sum of all of them. So there are here specific ones, but if you want to visualize them, these ones in animation, we can borrow a tool from the post processor from the autothermal comfort Solveig analyzer, and then we open this analyzer and we choose the folder. We can choose any folder. Let's choose this for now. And then we can show the animation, and so automatically it will be animated. What you can do is you can save this information, the tips, or you can record the animation using the Power software or any other software, screen capture software, video software available online. Camtasia, I don't know, there are so many software there. You can save it in different formats. You can change the axes and the spacings between the values. In this case, it's not a big problem. So you want to run again the animation and see how the sun changes during the day. Now you choose the other folder. Let's close this. Continues opening. It just got crazy. Now let's choose another folder, which is this one. And let's close this. Okay. And then we put show animation, and as you can see here, the animation will different because we'll consider the trees. Okay, so you see here the shade from the trees. Okay, the tool, obviously the animation got crazy repeatedly opening. This might be a bug. So we close this, we close, forget about it. Anyway, so it just got crazy. So here you have a brief introduction to the UMEP, the basic solar radiation tool and how to use a post processor. In the following video tutorial, I will introduce the autothermal comfort analysis Solveig. So stay tuned. That will be posted very soon as well. And I hope you enjoy and find this UMEP tool very useful for you. Thank you very much and see you next video. Bye-bye.